Fluidized bed boiler technology. This is one of the most widely used boiler technologies in Vietnam and many developing countries around the world, especially for biomass fuels. The defining feature of a fluidized bed boiler is that the fuel is continuously mixed with oxygen inside the combustion chamber. Instead of remaining stationary on a fixed grate or moving slowly across a traveling grate, the burning fuel in a fluidized bed boiler is vigorously mixed by combustion air supplied from below. As a result, the fuel comes into much better contact with oxygen, allowing combustion to become more intense, more complete, and more efficient. One of the greatest advantages of a fluidized bed boiler is its excellent fuel adaptability. A fluidized bed boiler can burn a wide range of fuels, including wood chips, rice husks, sawdust, tree bark, wood pellets, Indonesian coal, cashew shells, straw, and many other biomass residues. However, being fuel flexible doesn't mean every fuel will perform well. Even with a fluidized bed boiler, key fuel properties such as moisture content, particle size, impurity levels, fuel consistency, and ash content must still be carefully controlled. If the fuel is too wet, contains excessive impurities, has oversized particles, or changes too suddenly, the boiler can suffer pressure drops, incomplete combustion, higher CO emissions, increased fuel consumption, and difficulty meeting environmental standards. Even so, compared with fixed grate and traveling grate boilers, a fluidized bed boiler is still far better at handling difficult fuels. In Vietnam, many biomass fuels commonly have moisture contents as high as 40% to 50%. Nevertheless, if the combustion chamber is properly designed, the air supply is correctly adjusted, and sufficient heat is maintained in the combustion zone, a fluidized bed boiler can still operate efficiently with these fuels. Basically, fluidized bed boilers can be divided into two main design approaches. The first is a fluidized bed boiler with a sand bed. The second is a fluidized bed boiler without a large sand bed, commonly referred to in practice as a semi-fluidized bed or vibrating grate fluidized design. This design uses a layer of sand or other inert material at the bottom of the combustion chamber. Air is supplied from below at a velocity high enough to fluidize the sand, making it behave like a boiling liquid. Fuel is then introduced into this hot sand bed, where it burns in a continuously mixed environment. The main advantage of a sand bed is its excellent heat retention, which helps burn certain difficult fuels while maintaining a stable and uniform combustion process. However, a sand bed also has several disadvantages. First, fluidizing the sand requires larger combustion air fans, resulting in higher electricity consumption. Second, the constantly moving sand can cause severe erosion of heat transfer surfaces, air distributors, water tubes, and other components inside the combustion zone if adequate wear protection is not provided. Third, this type of boiler generally performs best with fuels that have uniform particle sizes, low impurity levels, and relatively stable load conditions. If fuel characteristics change frequently, as they often do in Vietnam, successful operation requires considerable experience. Fluidized bed boiler without a large sand bed, semi-fluidized bed. In Vietnam, many biomass fuels, including wood chips, rice husks, sawdust, tree bark, cashew shells, and straw, ignite relatively easily, even though their moisture content may be high. Imported Indonesian coal is also generally easy to ignite. Therefore, in many cases, maintaining a large sand bed is not actually necessary. Instead, the combustion chamber can be designed as a semi-fluidized or vibrating grate system, where the fuel, hot ash, and burning fuel bed are continuously mixed to create a stable combustion zone without maintaining a large traditional sand bed. Eliminating the large sand bed offers several advantages. First, combustion air fans consume less electricity. Second, the risk of sand erosion is significantly reduced. Third, it is better suited to Vietnam's diverse biomass fuels. Fourth, when steam demand fluctuates, the boiler can still respond effectively, provided the fuel feeding, air supply, and control systems are properly designed. This is one of the main reasons why this type of fluidized bed boiler has become widely used in Vietnam. Fluidized bed boilers generally require a higher initial investment than fixed grate or traveling grate boilers. In return, however, they can utilize lower cost fuels, achieve more complete combustion, reduce fuel consumption, and more easily comply with environmental regulations when properly designed. Fluidized bed boilers also offer a much higher level of automation than fixed grate and traveling grate boilers. As a result, dependence on manual operation is significantly reduced, Nevertheless, stable operation still requires operators to understand the fuel, air supply, fuel feeding, routine maintenance, operating parameters, and how to respond to abnormal conditions. At DIVI, this type of boiler is designed across a wide capacity range from 2 tons of steam per hour up to 30 tons per hour, and in principle, it can be engineered for capacities of hundreds of tons per hour. In some countries, fluidized bed boilers are typically designed only for capacities above 25 tons of steam per hour because traditional sand bed technology involves relatively high investment costs. However, in Vietnam, due to its specific fuel conditions and practical experience in designing, manufacturing, and operating biomass boilers, fluidized bed boilers can also be optimized for smaller capacity ranges. Pulverized fuel boiler technology. This technology is typically used in power plants and other very large-scale boiler systems. In this system, solid fuels such as coal must first be ground into extremely fine particles, typically measured in micrometers. The pulverized fuel is then injected into the combustion chamber together with air, where it burns while suspended in the furnace. The advantage of this technology is that it is well suited for very large capacities, providing intense combustion and high efficiency in power generation applications. However, it requires highly uniform fuel, consistent quality, extremely fine particle sizes, and sophisticated grinding, injection, and control systems. Therefore, it is not suitable for the diverse biomass fuels commonly used in small and medium-sized industrial plants, where moisture content and particle size often vary significantly. Consequently, in conventional industrial applications, especially for boilers below 100 tons of steam per hour, this technology is rarely used. So far, we have classified solid fuel boilers according to their combustion methods. By now, one important point should be clear. The combustion technology must always be selected based on the fuel. Boiler capacity alone should never be the deciding factor. Instead, you should evaluate the fuel type, particle size, moisture content, heating value, ash characteristics, environmental requirements, and fluctuations in steam demand before selecting the most appropriate combustion technology. I hope this video is helpful to you. See you in the next videos. Thank you.